Welcome back to another video. In today's video, we'll be going over parent functions and their transformations. We'll learn how to graph and analyze them. For the sake of this video, we'll be going over 4 parent functions and their transformations. So let's go ahead and get started with this video. For our first example, we'll be starting with a constant line graph. This will be indicated with f of x being equal to a number. Let's go ahead and take, for example, 6. These are the easiest to graph because you can draw a straight line through the y coordinate. So since our value is 6 here, this is the same as y equals 6. So we'll go ahead and navigate to the y value of 6 and place a dot right there, and we're just going to go straight through it, just like this. And that's basically how you graph this. For the domain of this function, it'll be from negative infinity to infinity. And the range will always just be the number y is equal to with brackets on each side. I think some teachers may take like 6, 6, but I think 6 just makes more sense, so I would just stick with this one. Alright, let's move on to our other parent function. There's not many transformations you can do when y is equal to a constant because it just depends on what the number you're given is. So there's really no general rule you need to know other than just plotting a point at the y value you're given and just drawing a straight line right through it. So let's go ahead and take a look at linear functions. These are also pretty easy and are indicated by y equals mx plus b, with m being the slope and b being our y-intercepts. So how would we graph a function like y equals 2x plus 4, for example? So first we'll draw a graph. And once again, this is our y-intercepts. This 4 is our y-intercept. So we're going to go ahead and navigate to 4 as a y value and plot a point there. And then we're going to use rise over run. I'm sure you've learned that, which is the same as our slope. Our slope here is 2 because that is our m value, which is the coefficient in front of the x. So 2 as a fraction is the same as 2 over 1. So our rise will be 2 and our run will be 1. So as in rise, it means going up 2, so 1, 2. And then going right 1, which is our run. So it's going to be right here. And we can also apply this going backwards, so we'll go down 2 and left 1. And then we'll go ahead and draw a straight line through those points. So that is how you graph a linear function. This is the easy way to do it. This is the textbook way to do it, and I would say do this every time on an exam or a quiz. It's very quick and efficient. So for our domain and range, it'll always be negative infinity to infinity for both. Make sure you keep that in mind. Unless there are restrictions like a piecewise function, obviously the domain and range is going to be different. But if you're given just a linear graph, the domain and range will always be negative infinity to infinity. So make sure you include that in your answer. Let's go ahead and move on to our third parent function. If you're finding this video helpful so far, feel free to drop a like and subscribe. For our next example, we'll be looking at quadratic functions. You need to know how to graph quadratic functions. I'm sure in Algebra 2 you've learned how to graph quadratic functions, and you're going to need to know how to do it in Precalculus as well. So quadratic functions is when you're given y equals ax squared plus bx plus c, with a, b, and c being constants or fractions, just numbers in general. So let's go ahead and take a look at an example. Let's say we're given y equals x squared plus 2x plus 3. How would we graph this quadratic function? So looking at this example, we obviously have a few transformations. Normally you'll be given like y equals x squared, but obviously the numbers is not 1 and 1 and 1, it's 1, 2, and 3. So if you know anything about a quadratic function, you know that they're in the general shape of a U. So just keep that in mind before or when we're graphing this function. So let me go ahead and draw a graph. Now let's go ahead and find our vertex. This is the starting point of quadratic functions. It's really important that you know how to find the vertex. So to find the vertex, you need to know negative b over 2a, which gives you the x value of the vertex. So negative b, this is b in our situation. Make sure you take a look at these a, b, and c's. We're just going to plug in those numbers into this equation. So our b in this example is 2. So we're going to have negative 2. We're going to negate that. If this was a negative 2, it would be positive 2 because you want to negate a negative, which just makes it positive. So make sure you keep that in mind. And our a here is 1. If there's no number in front of an x, the coefficient will always be 1. So it'll be 2 times 1, which is the same as 2. We'll get negative 2 over 2, which equals negative 1. So our x value for our vertex is at negative 1. Now we need to find our y value. So to find our y value, we're just going to take this x value we got out and plug it right back into our equation right here. If we plug in negative 1 for x, we'll get negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared, any negative number squared is the positive, so negative 1 squared is 1, minus 2, because 2 times negative 1 is negative 2, plus 3. 1 minus 2 is negative 1. Negative 1 plus 3 is 2. So our vertex will be at negative 1, comma 2. Let me go ahead and clear this off. So that's how you find the vertex. That's a pretty simple way, I would say, to find the vertex. So now that we have that done, we want to go ahead and plot some points. So next, we want to go ahead and graph our shape. Now, most of the times, teachers will require 2 to 3 points being plotted on your graph. They won't just take the vertex because that's way too easy. So we're going to go ahead and plug in some numbers and get their outputs, and then we'll go ahead and graph those points. So let's go ahead and find our y-intercept. We'll have our vertex and y-intercept, so that should be around enough. So we'll have a total of 2 points with our y-intercept and our vertex. So to find the y-intercept, we have to plug in 0 for x. So we're going to get y equals 0 squared plus 2 times 0 plus 3. 0 squared is 0. 2 times 0 is 0. Add 3, so our total will be 3. So our y-intercept will be at 0, comma 3, which is right here. If you're advanced with parabolas, you will know that your next point will probably be at negative 2, comma 3, because parabolas are symmetrical on both sides. Teachers might require you to show your work for that though, but I'm not going to go through that. So our graph will look something like, let me get a different color actually. So our graph will look something like this. And that is how you graph a parabola. So now we want to find our transformations. So a parabola will always start at the origin, which is 0, comma 0. So if we take a look at these two functions, how do they differ? Well, first we went up by 2 points. We moved up 2 and we moved to the left 1. So if they ask what are the transformations, you just list that in sentences, I guess. So let's go ahead and find the domain and range. The domain for quadratic functions will always be negative infinity to infinity. Make sure you keep that in mind. And the range will be from our vertex to infinity. So it'll be from 2 to infinity because our range is our y values. And our lowest y value here is 2. And our highest is infinity as indicated by the arrows. If you're finding this video helpful so far, be sure to like the video and subscribe. And if you have any further questions, you can join our Discord server, which is linked in the description below. Last, we'll go ahead and do absolute value functions. An absolute value function is like when you're given f of x equals x, and they will look like a V shape. So just keep that in mind as we are graphing this function. So let's say that we're given f of x equaling x plus 3 minus 1. By the way, f of x and y are used interchangeably in this video. They're the same thing, they're just referred to differently. It doesn't matter. Most of the times on tests, it will probably be f of x instead of y because it's just more formal, I guess. So let's go ahead and graph this absolute value function. So we want to go ahead and take a look at the numbers here and here. So anything inside the absolute value like markers, like these straight lines right here indicate an absolute value. Any numbers inside that, we want to set this total equal to 0. So if we set x plus 3 equal to 0, we're going to get x equals negative 3. And that's going to go ahead and be our x value of our vertex. So we know our vertex is going to be somewhere at negative 3, but what is our y value? So the y value will be this number on the outside right here, which is negative 1. So it'll just be negative 1. So our vertex will be at negative 3, negative 1. So to find the vertex of an absolute value equation, you want to set the inside equal to 0. And then you want to go ahead and use this number at the end as your y value. And I'll go ahead and show you why that is in a second. But if we plot this, it'll be at negative 3, 1, negative 3, negative 1, which is right here. And we can go ahead and plug in some points just so that we can get a total of 3 points. So let's go ahead and plug in negative 2 and negative 4 because those two numbers are very close to negative 3. If we plug in negative 2, we'll get negative 2 plus 3 minus 1. That's 1 minus 1. Absolute value of 1 is 1, and 1 minus 1 is 0. So our point will be at negative 2, 0 because we plugged in negative 2 and got out 0. Let's go ahead and plug in negative 4 as well. If we plug in negative 4, the absolute value of negative 4 plus 3 is negative 1 minus 1. Absolute value of any negative number or just any number in general is just the positive of that. So the absolute value of negative 1 is 1, and 1 minus 1 equals 0. So our second point or our third point will be at negative 4, 0 because we plugged in negative 4. We plugged in negative 4 and we got out 0. And then we can go ahead and use a different color here. Then we can go ahead and go through the points. Remember, it's a V shape. It's not curved like a parabola. Just straight up like this. So that's how you graph an absolute value function. If you take a look, it is also symmetrical, just like a quadratic function. So if you know that a point's going to be here at negative 2, 0, like, because we moved over 1 and up 1, it'll be the same on the other side. So we move over 1 and up 1. So that's just a general thing to note in case you need to remember that, to like quickly plot the graph on a exam. So let's go ahead and explain why our vertex at -3, -1. So it's the same thing as like a parabola. Let's say this was a parabola instead. Or if you put it in like the parabola form, if you know anything about parabolas or like cubic functions, the inside is always, this number right here on the inside is always negated for like the x value. So since this is +3, it'll be -3, because if we set it equal to 0, we get -3. And this number on the outside always dictates how the graph moves up and down. So the number on the inside dictates how the graph moves left and right, and this one dictates how it moves up and down. So since it's -1 here, you move the graph down 1, and since it's +3 here, you move the graph left 3.